And then going to part C, which is the last part of this example 4. Part C says that we need to find Z1, Z2 in the polar form. So let us find what is Z1, Z2. Z1, Z2 means Z1 times Z2. Where is Z1? Z1 is 5i minus 2 times Z2 negative 3 plus I. We have learned multiplication of complex numbers, and I expect you to get the answer for this before we proceed. Okay, welcome back. 5i times negative 3, that is negative 15i. 5i times I, that is positive 5i squared. Negative 2 times negative 3, positive 6. Negative 2 times I, negative 2i. Then we will see we are going to have negative 15i minus 2i, negative 17i. This one is, it has, let me do plus 5 into negative 1 plus 6 now. That means here we shall have 17, negative 17i, negative 17i plus 1. This is going to be negative 5 plus 6 is plus 1. So therefore, this is the value of Z1, Z2. What do we need to do? We need to find the magnitude of this Z1, Z2. That means our R becomes the square root of x. X is 1. That is the real part of the complex number squared plus the imaginary part is negative 17, then squared. I expect you to know this. So let me just write the answer straight away. 17 squared plus 1 squared under root. I'm getting root of 90 here. Square root of, not 90 actually, 290. Of 290. 290 units. You can leave it in that form to save your space, and this is the absolute answer. So after getting the magnitude of the complex number Z1, Z2, we need to find its arguments. How do we do that? By representing it on the diagram and say this is the real axis of Z1, Z2. This is the imaginary axis of Z1, Z2. This is the origin. Now we need to indicate negative 17 on the imaginary axis. So negative 17, assuming it is here, the corresponding positive 17 is there. And then on the real axis, we need to indicate 1. 1 should be closer to the origin somewhere here, and then negative 1 somewhere there. Now we need to represent this complex number. 1 is positive, it is there. Negative 17 is down here. So we just draw a straight line, find a point of intersection here, draw a straight line from the origin up to where the meet, put an arrow on it. And then remember that this is what I called Z1, Z2. Now we need to find the argument of this complex number. What the argument runs from here up to where the complex number is. I'm going to be consistent with what I've been doing. That means this side we know it is 90 degrees. This angle is 90 degrees. 90 degrees. But now we don't know this small angle, so that we add it to give us the argument. So let me call it maybe alpha. Now we know that from here up to here is 1. That means from here up to there is also 1. This side is 1. From here up to here is what we are calling 17 units. The negative shows that it is lying in the third quadrant. The signs show us where they are lying, but these are units when we are looking at their graphs. Now from here we are going to apply either sine, tan, or cosine because we know the magnitude of the complex number, which is the hypotenuse. To be consistent, let me say tan of alpha, which is my angle, is going to be opposite. Opposite is 1. Opposite to the angle is 1. Out of adjacent to the angle is 17. That means here my alpha becomes the arctan, which is tan inverse of 1 out of 17. Let me press your calculator. 1 divided by 17. Then you press tan inverse. It gives us here 33 point. It gives us 3.37 degrees. How do you press it? You just press shift and tan to write there tan inverse. Then you open the brackets and say 1 divided by 17. It gives 3.37 to 2 degrees. So this is the small angle that we have there. Now to find the argument. Now so therefore the argument becomes 270 at this plus that, and then plus this small angle 3.37 degrees. And then you press equal sign and press the calculator plus 270, 273, 273.137. This is the argument. Now, since we have the argument there and we have the magnitude r, we can write the polar form, whereby we can just say from z is given as r into cosine of theta plus I sine of that same theta. This means that here z1, z2 becomes, what is our r? Our r is here, root of 290. You can leave it like that, root of 290 into cosine of the angle, which is 273.37 degrees, plus, don't forget I, and sine of 273.37 degrees. That is one form. Or you can use the other form that z is given by r, theta. Whichever z now we are saying it is the same as z1, z2 combined. It gives us r is root of 290, our angle is 273.37 degrees. So either way, that is the same answer, and this brings us to the end of example 4.